Welcome back friends, welcome back in another video lecture from microbiology with Shagnik. In this video lecture series we are going to start a new topic, that is enzyme linked immunosorbent assay. I am going to explain all the about the enzyme linked immunosorbent assay in very details in near about 5 videos. One will be of introduction. Second, we are going to talk about direct ELISA. What is direct ELISA? What is their advantage and disadvantages? Then we are going to talk about indirect ELISA. Then we are going to talk about sandwich ELISA. Then we are going to talk about at last competitive ELISA. Okay, so we are going to discuss on 5 video in this video lecture series one by one. So today we are going to talk about introduction, what enzyme linked immunosorbent assay or ELISA is. Okay, so the full form of ELISA is enzyme linked immunosorbent assay. If we concentrate on the full term, then we can easily interpret what is the test is all about. Okay, so what is the full form? Full form is enzyme linked immunosorbent assay. That means we are going to use a enzyme linked molecule to detect a immunocomponent that are sorbent, that means that are adhered in a something of solid support. Okay, that we are going to detect with the help of a enzyme linked molecule. That is what ELISA is. So what we can say, so ELISA is a rapid immunochemical test. As we heard, we are going to find out a immunocomponent, so we can conclude that it is a rapid immunochemical test. Okay, this rapid immunochemical test is going to detect a immunocomponent that is with the help of a enzyme linked molecule. That is what ELISA is. Okay, so ELISA is used to detect components that must be have some antigenic properties. That means we can say antigenic property containing substance can be easily detected by ELISA technique. We can then easily conclude that with the help of ELISA we can detect protein like molecules rather than other small molecules and ions. Another important feature of ELISA is very sensitive and specific. Okay, and there are other many methods by which we can determine the immunocomponents. A similar method like ELISA is radial immunoassay, but among them ELISA is much more preferable because radio immunoassay, not radial immunoassay, radio immunoassay. So as the term suggests, we are going to take the help of radioisotope, and we also require some radiation counting apparatus, and that could be hazardous. That is why ELISA is much more preferable nowadays. Okay, so as we have talked about that ELISA is going to take in ELISA we are going to take the help of some enzyme linked molecule. Okay, so it is now necessary to find out what are those enzymes. Okay, so let me write it first. So these are the enzymes that we are usually use in case of ELISA. So one is horseradish peroxidase, second one is alkaline phosphatase, third one is beta galactosidase, and the fourth one is urease. These enzymes are linked with something. That is why the full forms tell us about enzyme link. That means we are going to use a molecule that is linked with the enzyme, those enzymes. Okay, and with the help of these enzyme linked molecule we are going to find out a immunocomponent or a component that bears antigenic properties. Okay, so once this molecule is going to attach with immunocomponent, we are going to add a colorless substrate that in presence of enzyme give us colored product. Okay, so now after learning about what enzymes we are going to use, now it is necessary to know about color substrate too. So the one important substrate is tetramethylbenzidine, that is specific for this one, horseradish peroxidase. It is usually a oxidizable substrate that in presence of peroxidase become oxidized. Okay, it takes the OH group from H2O2 and becomes oxidized. The reaction is something like that. H2O2, this is your TMB. So what do we have now? So what is going on? This TMB become oxidized into tetramethylbenzidine, the oxide, and water will be liberated. Okay. So similarly, this alkaline, in presence of alkaline phosphatase and beta galactosidase and urease, we are going to also add another substrate that is colorless in usual, but when they are after reaction they were converted into color product. Here the tetramethylbenzidine oxide gives us blue color, and this blue color is detected by any colorimetric measure. Okay, this is so that we can quantify as well as we can qualitative. That means whether it is our desired product is present in the sample or not, and what amount it is present, we can quantify both them. Okay, now the thing is what substrate we are easily going to use. The important substrates are tetramethylbenzidine oxide, tetramethylbenzidine. Another one is OPD, that is orthophenylene diamine. Another one is agino diammonium salt, and another one is amino salicylic acid. So these are the important substrates that usually colorless in nature, but when in presence of enzyme they are converted into colored product. Okay, so that is all about introduction of ELISA. In our next video we are going to talk about direct ELISA. So till then I hope it will be helpful to you. Thank you.